So as Florina introduced me, I am Blaize Stewart. I'm an Azure architect and a Microsoft MVP. So I spend a lot of time working in the Azure context. So um, that is what I do 24/7, pretty much. It's my job. And, again, I do write, but that's more for a hobby. But today I wanted to talk about Kubernetes, kind of from a general perspective, not so much around, I'm going to be using Azure for my demos, but I don't think that anything I'm doing today is going to be specific to Azure. It's not. It is a general purpose technology that works across a broad landscape of different cloud providers, but I focus on the Azure space. So most of my experience with Kubernetes is around Azure Kubernetes Services. But having said that, I'm not partial towards Azure Kubernetes Services. I generally like Kubernetes regardless of where it's deployed, and I've seen it on premise and worked with it a little bit on other clouds, but mostly in Azure. Let me tell you a little bit about who I work with. I work with an organization called Atmosera. We're a consulting partner with Azure. And we also do training and managed service providers, and that's just who I am. We work with GitHub as well, so I tend to work in the Azure space and do a lot of training and consulting in that space. But let's talk about Kubernetes, and then we'll start with a general concept of what we're talking about with containers versus VMs, and talk about containers for a little bit, and then I'll go and then we'll start to layer on top of that, because this is one of those things that is one of the core concepts, and that is, what is a container? Most folks are going to be familiar with the idea of a virtual machine by now. If you've been working in the tech space for any amount of time, you're going to know that a virtual machine uses a host operating system, and the host operating system then can be carved up to any number of virtual machines that run on virtualized hardware. And then you have a guest operating system, then your apps and binaries on top of that. So this is a fairly familiar concept, and we use it every day, all day. And this is not going away anytime soon. So we'll have virtual machines in Azure that run Kubernetes. We'll have them on premises as well. So this is a very familiar concept. Containers is becoming more familiar. It's basically the same idea, but the where it does the abstraction with a virtual machine, the abstraction is done at the hardware level. So we run virtual hardware, and then we install operating systems on top of that. A a container uses, basically, instead of using virtual hardware, uses a virtual kernel. And what I mean by that is, instead of running virtual hardware, what it does is it provides a virtual kernel at the abstraction layer for the virtualization, and then it allows the apps and binaries to run right on top of that API, essentially that virtualized kernel, so that we don't have to have a guest operating system and virtual hardware for those apps and binaries to run. So what this basically allows us to do is eliminate these two layers that we typically have in virtual machines with containers. And so our images and our binaries get better application density for the same compute hardware if you were running that on top of instead of like a virtual machine, where you have all this overhead for virtual operating systems and virtualized operating systems and virtualized hardware. This one, we can eliminate that and just have the guest operating system expose a virtual kernel that allows us to run apps and binaries on top of that. And it has some um, very tight binary, what's the word I'm looking for, application density running on top of that same hardware. So in essence, that's really what we're trying to get at. The trade-off for this is that we have an application affinity, basically an operating system affinity for the host operating system, because a Linux host can only run Linux containers, a Windows host can only run Windows containers. And that basically implies that any app or binary that I deploy in a container has to be able to run on the host operating system of the same kind. And so my Linux apps can only run on Linux hosts, and Windows apps can only run on Windows hosts for containers. Usually, that's not a big deal. So that is really what we're trying to aim for in this particular context. Though, with Kubernetes, what we can do is we can design a cluster that has both Windows hosts and has Linux hosts, and Kubernetes is smart enough to figure out which one of these is going to be able to run the image that I'm going to be talking about. So, a container workflow, this is important to understand, though, whenever we start to talk about building containers and deploying those to Kubernetes. So, if we can think about a container workflow, we typically have a local dev environment where we have what we call a Docker file. Now, I'm not going to get into the details of Docker file, but I do want to bring this up because a Docker file is basically a script that determines how to build a container image. And the Docker file then gets built locally using Docker build, or that's fundamentally what gets run under the hood to build a container image. Now, the container image is basically the copy that I'm going to be deploying to my Kubernetes environment. So it basically builds all of the dependencies into the container image. So if it's a web app, I'm going to need a web server, and I might need all the dependencies for the web server, and I might need the app runtime, and I need the binaries for my application. So all that gets bundled up into a container image. Say if it's a .NET app, a .NET Core app, I'm going to be bundling up .NET, the .NET Core runtime. I'm going to be running .NET and the .NET runtimes, as well as the DLLs for my application, and all that gets deployed into a container image. Now, the configuration, though, is something that I can later inject by way of environment variables that get exposed to it, or maybe some secrets. But whatever it is, all of the application runtimes, all of the various components are bundled up in that container image. Now, that's in the local context. I can run it in a local context using Docker run, but I can't deploy that to Kubernetes in this context. I need to push it to a container registry, which is the next step, which is Docker push. Basically, that takes the container image and pushes it up to a container registry. That could be like Docker Hub or Azure Container Registry or something like that. Now, once it's up in the container registry, now it is ready to be deployed to any number of instances of Kubernetes. I can deploy it to any other kind of environment that can run a container image. And then I use a Kubernetes command using the Kubernetes control or kubectl to create an instance of that container image using any number of mechanisms, which I'm going to talk about later. And it's basically just going to pull that down from the container registry to a local instance of Kubernetes. Basically, every node in my cluster is going to pull that image, and then it's going to run that image as a container. So it's going to pull down the container image, and it might spin up 4 or 5 or 6 instances of that in a given Kubernetes cluster, depending on however I configure the desired state to run. And once that's up and running in my Kubernetes cluster, it's ready to go. So that is the basic workflow for how Kubernetes works. So it's really not that complex, but there's a lot of plumbing that you can wrap around this basic workflow that gets a lot of value add. I'm mainly going to be talking about Kubernetes pulling the image from a container registry down to Kubernetes. I'm not going to be talking a whole lot about this build process over here. I'm mostly going to be concerned about Kubernetes. So Kubernetes pulls a container and pulls it down to a local environment. It uses a something called a pod to wrap around that container. Now, a pod is the most fundamental building block on Kubernetes. Now, containers themselves are typically how we think about apps running on Kubernetes, but Kubernetes is by design able to run more than just Docker containers. It can run other container image formats, but most of the time, 99.9% of the time, when I'm talking about Kubernetes, I'm talking about Docker container images on Kubernetes. You can run Rocket, you can run one of the many other formats out there, but I'm mostly going to be talking about Docker images, Docker containers running in Kubernetes, which in 99% of the time, that's probably the case. So a pod then is basically a wrapper around a container that is running on Kubernetes. This is the most fundamental building block on Kubernetes, and it basically applies some abstractions around the container image that it's running. It provides the local storage for that image. It provides network connectivity for that image, and it also has some metadata that it associates with it. Now, a given pod can run multiple containers in a given pod. Having said that, though, the general best practice for running a pod is to have what we call a primary container and that's going to be the one that runs your app. And then you might have what we call sidecar containers, which would be supporting containers. Now, if you're running what we call something like a service mesh, uh, typically a sidecar container gets injected into every pod, and that basically brokers the communication by for all of the images, all containers running in a given pod. However, for our purposes today, we're going to be only going to be working with a single pod that with a single container in it, which for um, entry level purposes and for most cases, that's probably going to be good enough. And if you're running a sidecar container, it's usually because you're adding some kind of service to the pod by way of some kind of communications or supporting services that gets added automatically, and usually you don't have to worry about it. But if you actually view the pod, you might say, why do I have two containers in my pod even though I told it one? And it might be because there's something on Kubernetes that's injecting more than one container into the pod. But primarily, generally speaking, one container to one pod is probably what you want to do. Now, labels on pods are useful for filtering these, and there's other things that you can do with this that we're going to be looking at whenever we talk about services and ingress here in a moment. So that's basically the idea behind the pod. The pod is again just the abstraction around it, but it's just think of it as the most basic building block on Kubernetes. So you have pod names, you have the labels, and you have the storage, and then of course the pods. So once you have a pod defined, you have a definition of a pod that basically you tell Kubernetes, my pod is going to run this container image. We're going to be talking about controllers. Now, a controller in the Kubernetes context is basically the part of Kubernetes that manages the behavior of pods. So a controller then is going to be using code that is running on Kubernetes in some context that is going to tell Kubernetes, create me 3 pods and load balance those pods across my Kubernetes cluster, or create me 1 pod for every node on my Kubernetes cluster, or create me 2 pods for every node on my Kubernetes cluster, or tell me create only pods that run on Windows nodes for my Kubernetes cluster. That's what controllers do. They basically shape the behavior of how things run on Kubernetes, and they try to get something into a desired state within the context of the available resources of Kubernetes. So Kubernetes is fundamentally a clustering technology that we have, which we'll look at the how it all fits together in just a second. But the controller is the most fundamental control mechanism for how Kubernetes behaves. It's not making any assumptions about how you want it to behave. Rather, it expects you to define how you want the workloads to run on Kubernetes by way of defining a controller. And then the controller is then going to try to figure out within the context of Kubernetes what's the best way to do that. And there's a lot of various knobs and dials and switches that you can use with controllers that will shape how your application behaves. Fundamentally, it's about defining a desired state, and the controller is going to try to figure out how to make that a reality. So there's a lot of different kinds of controllers on Kubernetes, which we're going to look at a couple of these today, mostly around deployments right here. But these are some earlier ones right here that are still around. This is a fairly old slide, I think, but the main one that most folks use today for starting up a set of pods on Kubernetes is called a deployment. Now, a deployment is basically a set of pods that we start, and the deployment is a set of pods that have a bunch of different replicas of the same pod. So this would be for applications that have all the same code running in the pod. So I want 3 instances of it. I want 30 instances of it. I want 300 instances of it. Deployments are primarily how that is managed. Now, you might see some older documentation or older examples that use something called replica sets or replica controllers. These are some older ones that are still out there that you might still see around, but they basically do the same thing as deployments. There are some other ones I do want to mention, though. Stateful sets are useful for managing pods that you need. Managing things on Kubernetes that require a specific configuration. So if I needed a database on Kubernetes, which you can do, where I need a master node to come up first, this would be how you would do that using a stateful set. Basically, this would allow me to bring up a master node first, and then it would create the other nodes on that database cluster after the master node comes up. This is also useful for applications that don't have the ability to scale independently. They don't have that horizontal scale where I can just add new replicas to the state and load balance it across multiple replicas. This would be more from traditional applications on Kubernetes. Daemon sets are useful for applications that are distributed to every node. This is a good use case for things like DNS servers, where you want a local DNS, or maybe it's a database node that you want available on every node, or maybe it's a cache node that you want available on every node on the Kubernetes cluster. A daemon set basically ensures that there's at least one copy of a given pod on every node in your Kubernetes cluster. And of course, these down here are for scheduling jobs and running things that have a start and a finish with an output. So jobs would be things like running batch jobs for HPC, a high performance compute, or you need to run some kind of reports or whatever. Jobs can do that. And then cron jobs, of course, just basically takes jobs and runs them on a schedule. So these are very useful for big data workloads or for reporting type workloads that you want to run there. And of these two, I think stateful sets and deployments are the ones that I have. So let's talk about the Kubernetes architecture, and then I think we'll have a demo, which will talk about deploying something to Kubernetes, and we'll get past all the talking points here. So this is the basic Kubernetes architecture, and Kubernetes architecture is a master worker configuration where we have a master node or nodes rather, plural, and then we have worker nodes down here. And so whenever I'm working with a Kubernetes cluster, I am going to be I'm going to be working with the master node, and we're going to talk about the various components of this. It's not important that you understand what all of these do, or you don't have to understand what a kubelet does, or what a C advisor does, or what all these things. You don't have to understand the intricate details of how they work, but just understanding where they exist and why they exist is mostly good enough for most folks, because you're going to see the documentation or examples refer to these things because they are a part of a Kubernetes cluster. And so the kube master has basically four components: the API server, a controller manager, scheduler, and then etc. D for the state management. So it's basically the one that controls the behavior of all the nodes and what have you. Then the Kubernetes worker nodes are the ones that actually run your pods, and these are the ones that get deployed horizontally. So I can have a cluster that has 300, whatever, how many nodes I need to make sure that my workloads are evenly distributed. And the master is going to be basically telling these down here what to do, and it communicates by way of the kubelet right here. I think I've called that out right here. The API server is where you interact with the server as a developer and operator of Kubernetes. So you're going to be interacting with the API server, and the API server then is going to interact with all of these other components. It's going to interact with the controller manager. Remember, I talked about controllers a little bit, and the controller manager basically creates the controllers, and then the controllers then interact with the API server and the scheduler, which then the scheduler is responsible for actually spinning up the pods. It's what communicates with the piece down here, what we call it interacts with the key value store, which is where all the state is managed, and then it interacts with the kubelet. So the scheduler, the controller manager, again, is what creates the controllers, as we talked about a minute ago, and then the controllers then go to the API server, and then which goes to it says I need 10 pods. Then that goes to the scheduler. The scheduler then communicates via the API server to go down to the kubelet, which is the local daemon on a Kubernetes node. You'll see this term come up a lot inside of Kubernetes talk, and it's basically the agent that runs on all the Kubernetes nodes that's receiving data, receiving commands from the scheduler saying, create this pod, shut this pod down, do all of these various things within the context of its node that it's managing. So you want to make sure that you might see something called a virtual kubelet, and that's just an abstraction where you have a API on the kubelet that's running in virtually that allows you to create things like on Azure container instances. But whatever this is right here, this is basically the piece that runs on your node, your worker node that receives the commands and then spins up pods or shuts them down, whatever it might be. And then there's something called C Advisor. It's basically collecting telemetry and all that data and sending it back up to the master node so it knows what available resources are available on that. And that's also how you get telemetry out of this for reporting purposes on something like Prometheus or Azure Monitor. And then, of course, the kube proxy. This is an important piece because this is what exposes your application to the internet. And so, or this is how users interact with your application is by way of the kube proxy. And if we're going to create services on Kubernetes, it's going to be done by way of a kube proxy. And then this acts as a load balancer for distributing your application across the various nodes in your Kubernetes cluster. And then, of course, they have the pods, which you've talked about already. And then every Kubernetes cluster implements some kind of network driver. And the network driver basically provides a transparent network between all of your Kubernetes nodes. And so you don't have to figure out all of the networking between your nodes. So you'll have these virtual subnets that kind of stripe across all of your worker nodes. And what's happening is your network driver is providing that network abstraction so that if my pod comes up over here on this node right here, it can seamlessly communicate with a pod over here without having to figure out how to route traffic out of the network, out of this pod across a network that connects the two physical nodes or the two virtual machines together, and then routes it back up into this pod over here. It provides a subnet to all of these various pods in this Kubernetes cluster that allow me to seamlessly communicate for them within the context of a cluster. And it also provides a lot of the abstractions for interacting with the outside world. So it basically enables me to create externally exposed pods for running connections between all of my my end users and my application running in my pod. So it provides a lot of that plumbing for you. You don't have to worry about a lot of this stuff if you're running this in the cloud. If you're running this on Azure, the plugin for the network is already configured for you. You don't have to worry about setting all of these nodes up and provisioning that. You don't have to worry about creating all the master nodes or any of that. But understanding the basics of how Kubernetes works under the hood will allow you to understand what it's doing wherever I go to expose a pod, or when I go to expose a service to the internet, which we're going to talk about here in a minute. How the controllers are being worked, how everything is just basically being orchestrated in the context of Kubernetes. So this is not intended to give you a exhaustive knowledge of it, but just understanding these basic building blocks will give you a good idea of what is going on in your Kubernetes cluster, so that whenever you go to create your Kubernetes application, you're configuring basically all of these various components to work together to get you the desired state of your application so that it will run in Kubernetes. And so I know that's a lot to talk about, but let's go ahead and I think I have a demo here. We've talked about pods already. Let me go to a demo here. I guess we got some replica data here. Okay, let's talk about services now. And I'm going to do a demo of a service here in a minute. Now, a service on Kubernetes is a let's go ahead and do a let's talk about this in a minute. Let me go ahead and do let me go ahead and do a demo here, and let me pull up some code here within the context of this particular demo right here that's going to talk about a deployment. Now, before we talk about services, now I want to deploy an application in this particular demo using this code right here. This code is defines a deployment that is using a deployment controller. Now, this demo is going to deploy a single pod and expose it to the internet. Now, the reason why I want to use this particular demo here is because it shows you the working pieces that go into making a deployment work. So I'm going to talk about services in a moment and how that works, but this one right here basically creates a single deployment that is my a single pod that's going to work in the context of Kubernetes. And this brings together a lot of the things that we just talked about when we were talking about pods and talking about different kinds of controllers. So the deployment controller is what I'm going to be talking about here, and I'm telling it what version I want. So I'm using version 1 of deployments. And this is using a spec. And the spec down here is this is my pod spec. If I wanted to create a single pod in the context of Kubernetes, I would be using a spec that looks like this. This is telling me the actual number of pods. I'm sorry, this is telling me the number of pods I'm going to use, but this is telling me the actual information about the pod and how it's going to be deployed. So this tells me I want to use this container image right here, the image pool policy, the name of the this is basically the name of the pod, and it's going to amend that with some metadata, and then it's going to tell me what ports are exposed in this particular pod whenever I create this. Now, once I had the pod spec defined right here, the deployment controller is then going to take this information and then create so many replicas of that. And I only have one specified here for this deployment. So I only have a single replica. Now I have a service up here defined so that I can actually get this on a network. And we'll talk about how that works in a minute with another demo. But this is my most basic deployment right here that's going to run this. So let's go ahead and deploy this code right here. So I already have this wired up to use a Kubernetes cluster that I've defined on Azure. So to run this, I'm going to run kubectl, and I'm going to use apply or create. I can use either one and do -f. And this is going to create this particular pod and a deployment running on Kubernetes. So if I go kubectl get pods, I can see that this pod is already running. Now this already pulled down the image for me. This is a fairly large image. I went ahead and preloaded it, and now it's up and running. So if I run Kubernetes commands, I can do kubectl get pod or describe pod right here, and this will give me information about the pod itself. And this tells me everything like that I did right here. So this, you can see it hit the scheduler, the default scheduler right here, and it assigned this to run on this particular node right here. This node right here on my Kubernetes cluster. So that's why it's calling it a scheduler right here. Then the kubelet does something. That piece that runs on the actual node, the agent that's running there, it's doing actions because the scheduler told it to do something. And it pulls the image, it pulled the image down, and then it's running the container right here, and it's starting the container right here. And so this is using this is just metadata about this. This is telling me various information about it that is useful for various things in this. So that's just telling me about the pod. So if I want to get deployment, if I do get kubectl get deployment, this is going to tell me the name. It's going to pull the deployments that I have currently running here, and I can do the same thing for describe deployment key right here. And that's going to tell me about this particular deployment right here. And this is using a deployment controller. That is one that I just mentioned a minute ago. And it's basically a scaled replica of set of this particular set of pods right here to one. And if I had three, which I will do in a minute, I'm going to show you that I can use 3 pods in a deployment. And it's using a rolling update. So this is using some basic information about this deployment. And once it's running, I have something up and running. So I'm going to use kubectl to get the IP of this as well. I'm going to get it from the service, which we're going to talk about. I'm going to show you the architecture of that. Kubectl describe service, service or get service rather, and this will list the services right here. And this is the external IP address for my service. And let's go ahead and launch a new browser window right here. And let me pull this over right here. And then let's just do HTTP to that IP address. And I'm going to click on this file right here. And this is just my application now. And this is running a little DOS emulator on Kubernetes now. So this is running DOSBox, if you're familiar with that. This is a little game. And what I did is I just basically installed an old DOS game on a pod here, an old DOS game in in a DOS environment, old MS-DOS environment, and then I'm streaming the results back to a browser. So this allows me to play this game in a browser, streaming this back to my local box here, and this is all running in the context of a pod running on a Kubernetes cluster inside of a browser using a web app. So it's basically just a simple little application that allows me to install different DOS games. And this one is Commander Keen. If you've ever played this, it's about I don't know, this game is over 30 years old now. And I played it when I was a kid. So I'm dating myself a little bit by the fact that I'm confessing to playing this old game that I played when I was like in third grade. But in any case, this is a fun little game that I've installed here. So that is how a deployment works. So let's go back to let's look at services now. And let's talk about this option now. A service, now that I've talked about the deployments for getting like a replica set or a deployment set up right here, a service can then load balance across various nodes on my clusters. So a service like this basically is a TCP load balancer. So it uses the kube proxy to load balance a TCP or UDP based application across different nodes on my different Kubernetes nodes. So a given replica set on a given node might have 3 or 4 instances of that running, but the load balancer, the kube proxy, is going to use that underlying network technology that we talked about, using a network plugin to have users come in from the cloud, and it's going to farm out traffic based on a load balance configuration to the pods that are going to be running across my different Kubernetes nodes. Now, the service is interacting with a deployment to know how many different pods are up and running, and that way it knows how to load balance that across a given cluster. So if my cluster has 15 nodes, if I define a service, then my service is going to know exactly where to send that traffic, and I don't have to worry about figuring out exactly what nodes to deploy to. I just say, I have 15 nodes, Kubernetes, I want 15 instances of my application, and Kubernetes is going to try to distribute that the best it can across the available nodes, and then the service is going to interact with that deployment controller, and it's going to say, hey, I've got 3 running on my first node, 1 running on my second node, none running on my third node, 2 running on my fourth node, or whatever the load balance configuration is. And it's going to know exactly where to send all that traffic. I don't have to configure the IPs, the ports, or any of that. I just tell Kubernetes, this is how I want this in a desired state, and then it's going to figure out how to make that work. If one of my nodes goes down, then it's going to try to redirect and and create new instances of my application on a new set or new replica set and bring that back up to a healthy state. And the services and the load balancer are going to respond according to that configuration. So let's look at services now. Let me get out of Commander Keen right here. Let's close this out and let's look at my services configuration right here, which I have in this particular demo right here. Now, this is using the same basic information that I had in my other YAML file that we just saw. I have a pod spec right here. This tells me what the container image is and the pod spec is. This one I'm using 3 replicas. I want 3 instances of this running. And then up here, I have the service defined. Now, my service definition right here is basically exposing a front end port and a back end port. And the back end port is defined down here based on my container port right here. So that's my back end port. And it uses a selector to tell what this is going to be running. So the selector is using the metadata down right here. And then the selector down here is using metadata down here inside of my template, which is then using so this knows the selectors are how we hook all this stuff together inside of Kubernetes. And I'm using the selector to tell the load balancer to go down here and look for this deployment for I called Node App 1. And so this one is exposing this using what we call a load balancer, which is basically a public IP address that gets load balanced across a bunch of internal IP addresses on my Kubernetes cluster. So this is not a nothing magical about this. There are other types of load services I can deploy. I can use what we call a node port, which basically uses a node, a local IP address on the internal network, and it just selects some port number and exposes my app that way. I can use a cluster IP address, which basically uses the IP address of one of the nodes to expose my application, or I can use the load balancer, which is basically trying to allocate an external IP address. In this case, I'm running on Azure, so it's going to grab a public IP address from Azure and use that to expose my service right here. And it's going to load balance that across this particular deployment right here. So this, again, is pretty straightforward. Let's go ahead and deploy this one. Let me go ahead and remove this other one right here. I deployed this one using apply. I can delete my deployment like this using that same file. I can delete -F, and that's going to delete that Commander Keen pod right there. And then I can then do an apply on, let's do an apply on this one right here, apply service deployment. I can do -F, and that's going to create my service right here that I've defined in my deployment. So if I do get service right here, we're going to see that this one is coming up right here, and this one right here is coming down from what we can see. This is the internal service that Kubernetes exposes for the API server, but this one is the one that's coming up right now. And then, so if I run this again, you can see that Commander Keen is gone now, and now I have this new one right here. This one came up, and if I do the describe on that service, describe service, and let's go ahead and grab this. It's going to tell me load balancing is up. It's going to tell me the internal IP addresses of my endpoints. Here's my node ports, my target ports. Here's my external port. Here's my load balancer ingress right here. And it's just giving me metadata about the service that it created. And it's going to try to load balance it across all of these different endpoints right here. And so if I do get pods, we should see 3 pods. Get deployment right here, rather. I should see that I have my node app is up and running. It's 3 of 3 is up. And if I do get pods, I should get 3 pods now. And all 3 of the pods are running. So you can see that I can use the kubectl to kind of get a state of everything that I'm running on my Kubernetes cluster right here. So let's go ahead and get that IP, and let's see what this looks like in a browser. Let's go ahead and launch a new instance of Chrome here. And let me pull this over to this window, and let's do HTTP. No, it's not HTTPS, it's just HTTP. And you can see that I'm running this is hitting one of these pods right here. It's hitting this one right here in the middle. Now, if I open a new window, let's see what happens. Let's refresh this. Let me grab this IP address. Let's see if I can make this hit another one. This one hit another F2P8W. F2P8W hit this one right here. And then if I open up a third one, let's see if it hits another one. F2P8W. F2P8W. I can't make it hit another one, but I did get. Let's open up an incognito node, and it still wants to hit that one. We did see it hit this one a minute ago, but it is load balance. It's trying to load balance between those, and it's maybe had some kind of session affinity. But you can get into the weeds and the load balance configuration inside of the service definition if you want to. There's different schemes of that. It's kind of outside the scope of what I'm doing here, but in any case, you can see that it is up and running, and we did see it hit 2 of the various nodes in the background using that load balance configuration that we have inside of this particular configuration right here. So there's another one right there. In any case, let's talk about the one last thing that I want to talk about inside for another demo, and that's the last conversation around ingress. Now, ingress is one of those things that is very important to applications, specifically around HTTP-based traffic. HTTP-based traffic uses ingress to get traffic load balance. So service is for TCP traffic. Now that's going to get you TCP load balancing across your nodes. And that might be useful for things like databases and other HTTP based services. However, ingress is what we're going to be using for HTTP based traffic. So this would be APIs or web apps or whatever it might be. And this is how we configure this. And this is what the architecture generally ends up looking like inside of Kubernetes. I have the cloud right here, and then I have an ingress controller that I deploy to my cluster. And then I can use route-based configurations to route traffic between different services in the back end. And so my services then expose different replica sets or deployments right here. So in my ingress, I'm going to be basically deploying my ingress routes to service endpoints. So the service endpoints will have exposing an IP address for my application, and then it's going to route the traffic through that service first by handling the routes through using HTTP based routing. So it comes in on port 80, port 443. It might do some SSL offloading, might do some URL rewriting, it might do something kind of header injection. It does a lot of different things with an ingress controller. There's a lot of things that you can do at that level. And then based on the route, that is, everything kind of after the slash, I'm going to be farming that traffic back out to a service. Then it's going to load balance that across a set of pods in the background. So ingress is for HTTP based front ends, like I said, and it also works for WebSockets and other things like that. So you can use it for pretty much any kind of web-based application. Supports HTTP, HTTPS, HTTP 1.1, HTTP 2. WebSockets, any kind of technology that is web related, you can use ingress controllers for. So let's look at how this looks like under the hood for a given ingress controller right here. Now, this is the same two demos I did just a second ago, and I rolled it up into a single deployment service ingress that I have defined right here. And so we're going to see the same services and the same basically the same services and the same deployments, but this time I'm going to expose them using HTTP ingress controller instead. So this one, you can see that I have my kind that's telling me what kind of controller I'm using. It's using an ingress controller. This is the API version. And this one is using an ingress controller of class Nginx. Now, there's no standard controller for ingress on Kubernetes. Nginx is probably the most commonly used one. However, there are ingress controllers for all kinds of different kinds of ingress handlers. So you could use Trafic or HA Proxy or Apache or Nginx, or you can use Azure Application Gateway. There's any number of different kinds of controllers that you can slot in. If you're not sure which one to use, just go with Nginx. It's probably the most commonly used one because it works well. It's easy to configure. It's pretty low overhead, and it's got high performance. It's got tons of features, and most applications will default to this one anyway. By default, there isn't one default that's installed on most Kubernetes clusters. You have to install one. It's usually 2 commands to get one of these up and running. Once it's up and running, everything just works. And I'm defining a bunch of annotations here, and this is basically what I use to configure this. I'm using new URL rewrites here. I'm using SSL. There's no SSL redirect. I'm using regex detection. This is for, this is basically, I need this for WebSockets because I am using WebSockets in this particular example because I did use WebSockets in that Commander Keen demo for the DOS app. And this is just using some different annotations on top of this. Now, this is all the annotations for configuring the actual ingress controller. That's not the important part. What is this stuff right here. And this is the routes that I was talking about a minute ago. So when I have my ingress defined, I'm just basically defining a number of URL-based routes based on the path right here. So everything after the first slash in my app path, that's what this is going to be talking about. So / right here is just the root. And that one goes to app 1. Notice I have the same app right here, app 1 going to that same backend service. And I did that on purpose so that you could see both of those routes defined. And then I have the same, I have another route defined here, app 2, and it's going to essentially the same app, but I have a different deployment of that same app running. So this one I called node app 2. The node app basically is just returning information about the server and the service. And we saw an example of that when I did my last demo. But this one is going to have a different deployment. So it's going to have 3 replicas, but a different deployment managing that. And this one, it has 3 replicas, but a different deployment managing it. So as far as Kubernetes is concerned, it's 2 completely different applications. And so app 1 and app 2 are one. And then, of course, Commander Keen right here. And notice I'm using a star dot a dot star right here. And that's because this one is using some relative path routing after it. So I want to be able to use that to capture anything that has /keen at the front of it to go to that particular deployment, which is going to expose that DOS emulator for the game that I was running a second ago. So this is identical to the service that we had a minute ago, except I'm using a cluster IP. I'm not exposing this publicly. I'm letting Ingress handle the public IP of this. So I'm just using cluster IP, which is fine. And then again, it goes back to port 80, target port 3000. And again, this spec is otherwise identical to the last one we had, other than it's using a different service to deploy it. Same thing here. I'm using an identical service. The only difference is this one's named differently. But it's using a front end port 80, back in port 3000. Cluster IP basically means it's using an internal IP address on the node cluster. So 2 different deployments, 2 different services for deploying that. And then again, this is the deployment for that. It's the same application, just deployed differently using a different deployment controller. Then down here, we have that first service that we saw whenever we looked at that Commander Keen, that DOS emulator. This one is using a different service and a different deployment to manage that one. So again, otherwise, the deployments and services are identical to what we have. But the biggest difference is that instead of using a service for public exposure, I'm using HTTP-based routing for ingress. So let's go ahead and remove this other service right here that I created. And let's go ahead and use the delete right here for this particular service. And let's go ahead and create this new one using my ingress controller. I'm going to do apply, and let's use ingress in service deployment right here, apply-f, and that's going to create a bunch of resources. This is currently being deleted. Yeah, let's make sure that it's currently being deleted. I might have to redeploy this in a second because this one is being deleted by the service that I just ran. So let's make sure everything's in a good state. So let's look at my ingress first. kubectl get ingress, and this should come up with a public IP address in a minute as soon as that gets exposed. But there's the public IP address. Now that that's exposed, let's get the describe of this. Let's describe this one just so that we can kind of see the details of it. And I called it HTTP ingress. That's my name for it. That's not the default name. And you can see that it's got several routes right here. And you can see in the back end that it's got the endpoints for that to expose. It's got the port numbers and all that good stuff as part of the exposure on these cluster IP addresses. And then there's all the annotations that are defined, etc. So you can see that everything is coming back to these various routes. And I can use various host header routings as well. There's all kinds of configurations, but it's kind of outside the scope of what I'm doing here. But you can see that I have everything just as I described it in my ingress controller configuration. Now let's get our routes just to see what this. Let's get our services right here. You can see that I have the default Kubernetes service, but I also have the node app services right there, and then there's the Commander Keen one. And let's get pods, and they should have, or rather, let's get deployments. I have the 3 deployments that I expected. I have my node app deployments. I have 2 of those as defined by my manifest file. Then I have my Kubernetes, my Commander Keen deployment. And if I get pods, I've been expecting to see 7 pods running. And I do. I see all 7 pods. They're all running. They're all in a healthy state. So everything looks good. So let's go ahead and get my endpoint IP address. Let's get that ingress. Let's get ingress again, so I can grab that IP address, and let's see what this looks like in a browser. So let me go ahead and get that IP address, and let me get a new window here. And let's close these out first. And let's go ahead and plug this one in right here. And notice this one is going to Node App 1. That's because the default route, as we recall right here, is going to Node App 1. And if I I'm hitting different backends now. If I refresh this, it's load balancing across that in the backend. Now let's put in /node app 1, app 1, and that's still hitting app 1. And then let's put in just some gobbledygook here. Let's see what happens. And that's going to node app 1 because it can't route anything. It's going to the root, and it's just passing that to the backend. Let's put in app 2 here, and we can see now that it's running in app 2. That's their backend route for app 2. And let's put in Keen now for this one. And let's see what happens for this. And put in PWD 123. That's my super secure password. I know what happened. I need to configure this right here. And there you go. And now I'm running Commander Keen again. And let's go C:. And let's let's run Keen 1. Install. And let's install my game here. And then we can run Keen 1. Launch the game, and everything's up and running. So that is, we've seen the actual various things that we can do with Kubernetes. So as a platform, Kubernetes is very powerful. We've seen it do all kinds of things. We've done a lot with this. We didn't cover ACR. I didn't go over that because that was kind of outside the scope of this. But in any case, with Kubernetes, Dave wanted to see if we had any questions or comments around this, or we can certainly call it a wrap if there are no questions.
First of all, thank you so much, Blaize, for the presentation. It was like brilliant walkthrough. Now I feel more confident while discussing with my colleagues who are good at Kubernetes. I'm not. I'm not a Kubernetes guy, but I deal with it in the context of our teams and everything. Now I feel more, empowered to, and I feel like I understand more about what they're discussing there. So.
Good.
Very good one. There is one thing that I would like to maybe address. It's regarding scalability. I mean, Kubernetes, it's designed to be highly scalable and to support high scalability. I mean, is there anything that you'd like to maybe mention here? And what's the largest Kubernetes cluster that you've seen or maybe worked
I think
with?
the largest one I've seen personally and worked on had a couple hundred nodes as part of it. It was on Azure. I think Azure will allow you to have up to, I think it's like 500 nodes on a cluster, but it was up there. And the thing about Kubernetes is it kind of scales two different ways. You have horizontal scale, which is adding new nodes to the cluster, but you also have vertical scale, because the vertical scale in Kubernetes basically is the size of the virtual machine that you're running, or the box that you're running on. So I can create a cluster that has a lot of large machine, a lot of compute power, a lot of RAM, a lot of CPU that can handle a lot of different pods on that same one single node. I can also have a bunch of smaller ones that can only handle a couple of pods. And I can mix and match because there's ways that I can have what we call node pools that have different classes of compute. I want big compute. I want a bunch of smaller compute nodes. I want Windows only nodes. I want Linux only nodes. I want smaller, single CPU nodes for running like just HTTP static content. I want multi-core processor nodes for running big data analysis and doing things like that. So you have a lot of different ways to scale it. Horizontally and vertically. It can literally scale to hundreds of nodes, thousands potentially. But in reality, it's most of the time it's dozens of nodes from most of my experience. But I've seen them go up to hundreds of nodes before.
Mm-hmm. Excellent. And while scaling, have you ever, I don't know, maybe noticed, performance issues, or because you usually have like an SLA, for.
The great thing about Kubernetes is it's got two layers of scaling. You have the scaling that's built into the nodes themselves. So, like if you run this on a cloud like GKE or Azure Kubernetes Services or AWS, um, the auto scale that you get with the nodes themselves is one way to handle that. So you can configure the nodes to add new capacity as you get more demand or scale it back, elasticity. And so if you need to ramp down under when demand is low, you can remove nodes from the cluster. So you have that layer of elasticity. And also the second layer of scaling is in the actual deployments that we looked at already with replicas. And so Kubernetes is going to try to load balance it across the available compute that's to it. So if one node is overtaxed based on the compute demand, say its CPU is constantly humming at above 80%, but there's a node over here that's more idle, it's going to try to move some of the work over to that idle node. And so Kubernetes is going to try to manage that as well as the backend. So you get great scalability and great within the context of Kubernetes, just at both layers. And that's something that you really don't get with other platforms.
Super, super, super. So Blaize, you're part of a community, the MVP community. So how did you got there? And I mean, what's in it for you being part of that community?
Uh, what's in it for me? Being an Azure MVP is a community that basically people that just love to share about technology. It's really, I mean, what's in it for me? Basically, I get to meet a bunch of people. I do get to talk to people about things I'm passionate about. So I love talking about Kubernetes, Azure, and all these kinds of different things. And to me, I just that's something I love to do. And so what's in it for me? I get to meet cool people. I get to go to different um, events and different meetups and webinars, and I participate in open source, and I write a blog. I run a small YouTube channel, interact with the community, the tech community at large, and that's really what's in it for me, is just being a part of that. And an MVP is not so much that I'm really good at this. I'm not. I just run my mouth a lot about it, and so I just really like to tell or share about it. And so, to me, the benefit of it is just being, part of the community and just sharing about technology and helping people understand it better and want to use it, and answering questions, and doing things like this. It's just part of it.
You're just being modest here, Blaize. You are good, and we're really thankful for the contributions in the community, because that's how we evolve. That's how we learn from each other. That's how we, I mean, from your experiences, I mean, from anyone's experiences, this is how we learn, actually. Now, one final thing, without any spoiler alerts, you're working on a novel right now.
Yes, I am.
Okay, so could you please summarize it for me? I mean, what's
Well, I have. Well, I've currently got. I'll just talk about the. I've got a series of novels out on. They're out on Amazon. It's called The Paladin Chronicles. I'm working on 3 novels right now. Actually, I'm writing one. One's in a drawer. I've written it already, and the 4th one I'm editing. So I've kind of got 3 in the works, and I've published 3 already. The one that I'm getting ready to publish, I'm about to release it probably in the next month or so, is the 4th one in the series, and it's about this a particular character that discovers that he's that gets caught up in this movement. Essentially, it's kind of a cult, if you will, and they end up having to they discovered this prophecy about the end of the world, and so they're trying to figure out how they might stop it. But at the meantime, they're having to this character betrays one of his friends, and ends up working with this kind of cult movement to kidnap her, and so some of the other people that are main characters go on this attempt to rescue her while having to deal with all of these other challenges to even get to her. And so the whole novel is about this emerging conflict that is between a lot of the main characters in the novel, that are between betrayal and this end of the world prophecy that they discover, and this attempt to rescue one of the main characters, that are all just kind of coming to a head. So there's a lot of dealing with all these struggles that they have with personally and interpersonally, and then this, global conflict kind of thing. So there's a lot of fun stuff going on in the novel. So that's the premise of it. So if you're interested in it, it'll be out in about a month. It's a sequel to the 3 first ones I've written. So they're out already and out on Amazon if you want to check those out.
Excellent. Thanks for sharing this.